All right, here we go. This is a video on lines tangent to the curve for implicit curves, and also specifically underlining horizontal and vertical lines tangent to the curve, because I know that there's been a lot of confusion. Before this video goes any further, please take a moment, read what is on my paper. Feel free to pause the video and copy this down. Think about it. You've seen it before. This is just some information that you have somewhere, but y equals f prime of c, x minus c plus f of c. This is the line tangent to the curve at the point c comma f of c. Don't forget that f of c is usually the y coordinate that goes along with whatever x coordinate that we're given. A very basic example of that, y equals x cubed minus 4x. You guys all know this. Looks something like this. If I want the line tangent to the curve, straighten this out, get you out of here. To y equals x cubed minus 4x at x equals 0. Well, that's pretty easy, right? My y coordinate will be y equals x, y equals 0 cubed minus 4 times 0. That'll equal 0. That's going to be my y coordinate that I plug in up here above. dy dx equals 3x squared minus 4. Right? Easy. Let's evaluate that at dy dx. Ooh, dear. Let's evaluate that derivative, dy dx. Evaluate it at x equals 0, right? This is a very easy derivative, right? There's no y in here. Implicit different derivatives are a little bit spicier. So my slope is 4, my ordered pair is 0, 0, right? At 0, 0, which is a point on this curve, dy dx, which is my slope, is negative 4. So my line tangent to the curve at x equals 0 is negative 4, x minus 0 plus 0, which if you distribute and add, you just get negative 4x, right? A downward sloping line. So the notation is just a little bit spicier as we start to work with things like this. And let's just try a random point. And watch how I write this a little bit differently. Find the equations to the curve x squared plus y squared equals 1 if x equals 1/2. So this says equations because there might be more than one. Now, let's just check. If x equals 1, I've got 1/2 squared plus y squared equals 1. 1/2 squared is 1/4. Subtract that from each side to get y squared equals 3/4. If I take a square root, y equals plus or minus the square root of 3/4. This tells us that now I'm going to have a line tangent to the curve at 1/2, comma root 3/4, and 1/2, root 3/4. Now, if you guys are negative root 3/4, if you guys are staying woke, you'll remember, okay, that makes sense. This is the unit circle. So if x is 1/2, right, this goes out to 1. If x is 1/2, you're looking at something in there. So we're trying to find the slope at this point and this point. Okay? Those two red lines. We have two y coordinates that match up with that x coordinate. So there's two different things that can happen. I will end up using this formula twice. Ultimately, my equations of the line tangent to the curve are going to look like y equals dy dx evaluated, this bar means evaluated, at the point 1/2 comma square root of 3 over 4. All this is one big gross variable. Multiply that by x minus 1/2 plus root 3 over 4. And I'm going to have y equals dy dx 1/2 root 3 over 4 x minus 1/2 plus negative square root 3 over 4. I need these now, so I need to do my implicit differentiation. X squared plus y squared equals 1. Give you a second to think about that. We've seen this before. 2x plus 2y dy dx equals 0. Subtract 2x, divide by 2. Subtract 2x, divide by 2y. dy dx equals negative x over y. Now, let's keep the task in front of us. We are still trying to find the equations of the line, of the curve, of the line tangent to the curve. Oh my gosh. To the... All right, so now let's evaluate. Once I evaluate this at these 2 points, right, 1/2 root 3 over 4 and 1/2 negative root 3 over 4, I'm going to be good. Dy dx evaluated at 1/2 root 3 over 4. Well, wait a second. Isn't root 3 over 4 equal to root 3 divided by root 4 equals root 3 over 2? Yeah. So this is really negative, what's my x value? 1/2 divided by root 3 over 2. Keep in mind, this negative is this negative. And let me just spread this out. 1/2 divided by root 3 over 2. Because this is YouTube, I can take as long as I want. Okay. So my first line tangent to the curve is going to be y equals negative 1 root 3 over 2, x minus 1/2 plus root 3 over 2. This is one of my lines tangent to the curve. Come back over here. Now I need dy dx evaluated at 1/2 root 3 over 2. And again, I can negative root 3 over 2. I can take as long as I want because this is YouTube. And you can skip the next, I don't know, 30 seconds if you'd like. Ooh, this is negative. The negatives cancel, so this is positive 1 over root 3. So I've got one slope that is positive 1 over root 3. Y equals positive 1 over root 3. X minus 1/2 plus negative root 3 over 2. This is actually a good video too for Unit 3, but if you're in Unit 3 still in AP Calc, you should stop watching because things are about to get a little wild. Because what if I wanted the equations of the line horizontal and tangent to the curve? Find the equations of the horizontal lines tangent to x squared plus y squared equals 1. Well, we already know that if we're looking at this curve, dy dx equals, what is it? Let me look at my old papers, negative x over y. Horizontal lines tangent to the curve occur where dy dx equals 0. Remember our very friendly, this is just an aside, so I'm going to put this over here. Remember our slopes, right? You've all seen this if you're in Unit 5. If you're so deep into Unit 5, you're looking at implicit relations. These line up, right? The slopes are equal to 0. The tangent line is equal to 0. Very flat, very demure, and all that. So I need my derivative to be equal to 0 at those points. Now, let's set negative x over y equal to 0. I want to figure out where is my derivative equal to 0. That means I want to get, let's just solve. Why do we solve for the numerator? Well, if I want my denominator, if I want my fraction to be equal to 0, I need my numerator to be equal to 0. But let's just say, why does that matter? Because if my numerator is equal to 0, like 0 divided by 5 is 0, right? 0 divided by 8 is 0. 0 divided by 11 is 0, right? Whenever your numerator of a fraction is 0, your whole fraction is 0. So that's why we look at our numerator to figure out the slope of the tangent line. So negative x equals 0. Well, negative x equals 0, x equals 0. Well, what do I do now? Right, because in a tangent line situation, right, you guys hopefully are still thinking like, all right, well, I need y equals, I need some sort of slope, x minus whatever x coordinate that I'm looking for, plus the corresponding y coordinate. Let's call this, I'm going to call it y at x equals c. And this is a new stupid variable, y at x equals c. But why do I have that? Because x squared plus y squared isn't a function. So I already know if x equals 0, right, that's my c. dy dx at x equals 0 will be 0 over y equals 0. So 0 will be my slope. Now I need my y at that value. That'll fill into this. Well, how do I do that? I look back here to figure out, all right, on the unit circle, if x is 0, what's y? Well, shucks. 0 squared plus y squared equals 1. Y squared equals 1. Y equals plus or minus 1. So I have two possible y's, which means I have two possible equations. Now, look at this, 0 and 0. Let's just write my different equations straight like this. Because I know there's some question like, oh, why is horizontal y equals? Because now horizontal means that your slope is 0, so your derivative is 0. If I multiply 0 by all this, all I'm left with is y equals 1, or y equals negative 1. Right? This becomes this. So I'm still using the same formula that I have been using all year, right? Because you guys have been doing this since September, right? September, October, November, December. We've been using this same f prime of c, x minus c plus f of c. You guys all write it on your homework. We're still using the same thing. Horizontal just means that my slope is equal to 0. My first derivative is equal to 0. Let's do the same equation. Find the lines tangent to the curve that are vertical if x squared plus y squared equals 1. And again, this is very much like, this isn't about implicit differentiation. You will need to be very good at implicit differentiation if you're going to survive. But I want you to focus on the calculus that's going on here. Now, I want my slope to be equal to 0. I need to have x equals. This is a good spot. If I were good at YouTube, I'd like demarcate. What do these implicit differentiation questions look like? Trying to find the slope, the horizontal tangent lines and the verticals. I'm going to do y equals 0. Y is my denominator. Because my denominator is equal to 0 now, my slope will be undefined. That's that vertical line. Right? Y equals 1, y equals negative 1. Y equals 0 is the y coordinate that will give me a vertical tangent line. So I'm going to take this value. I'm going to figure out what values of x satisfy this. X squared equals 1. X equals plus or minus 1. So these x's, they're not coordinates. These x's are now lines. These are the equations for lines. So much is happening, Mr. Slaney. Let me just graph what we just all found. This is my crappy unit circle. It goes out to 1, 1, negative 1, negative 1. My vertical lines that are tangent to the curve are these. X equals 1 and x equals negative 1. Similarly, if I just redraw this again, my horizontal lines are these. Y equals 1. These are my horizontal lines. This is y equals 1 and y equals negative 1. If you really want to, you can call this y equals 0, x minus 0 plus 1. Or y equals 0, x minus 0 minus 1. They're the same. This one's just a simplified version. Let's look at a harder problem. It's right over there. Give me 1 second. I'm walking across the room. I'm going to run back. Ooh, we're looking at a harder one now. Let's consider this problem that we all saw for homework. X cubed plus y cubed equals 6xy. And not to get bogged down in the details, the derivative is 2y minus x squared over y squared minus 2x. And again, the task, find the equations of the lines horizontal and tangent to the curves. So, what do I need for a horizontal line? What do I need for any line except for a vertical line? Well, y equals, I need a slope, which will be 0. I need the x minus c, so I need to figure out which c and which y at c. Right? I need these really. So I need to figure out which x and y coordinates result in a 0 derivative. That's how I'll make my line. So now, 0 equals, once again, the numerator for the horizontals, x squared equals 2y, x squared over 2 equals y. This tells me how x and y need to be connected, and this is where the systems of equations from Algebra 1 come in. Because now I'm going to take this. I know that's how x and y need to be connected. The other way that I know that they're connected is with this. Plugging this in, I mean, you've seen it in class. My x cubed plus x squared over 2 cubed equals 6x x squared over 2. Not to get bogged down in algebra, x to the 6th over 8, right? 2 cubed equals 3x squared cubed. X squared over 8 minus 2x cubed equals 0, x cubed. X cubed over 8 minus 2 equals 0. X equals 0. X cubed over 8 minus 2 equals 0. Add 2, multiply by 8. Take a cubic root. X equals the cubic root of 16, or the 1/3 power. Sorry, I am tight on time on this end of the world as well. So these, remember our task, this is the horizontal curves that are tangent to the line. This is my x-coordinate. I have one x-coordinate that's that, one x-coordinate that's that. I'm going to take these now and plug them back in here. Right? X squared over 2 equals y. If x equals 0, 0 squared over 2 equals y. 0 squared is 0. 0 divided by 2 is 0. So this says that one of my lines tangent to the curve, I already know that my slope is 0 because I'm looking for a horizontal line. So dy dx is 0. My line tangent to the curve here, y equals 0. That's the slope. X minus zero, right? Because this I got if x equals 0 plus 0. This is just y equals 0. So now y equals 0 is the horizontal line, is one of the horizontal lines tangent to the curve. Conversely, if x equals the cubic root of 16, y equals the cubic root of 16 squared divided by 2. This is equal to 16 to the 2/3 power divided by 2. That's my y-coordinate. Again, making my line tangent to the curve, my slope must be 0 because I am a horizontal tangent line. X minus, let's see, the square root of 16, the cubic root of 16, that's my x-coordinate, plus 16 to the 2/3 over 2. Guess what? 0 times this is 0. So this is really just y equals 16 to the 2/3 over 2. All right, that's the horizontal. Very connected to what we've done so far in the course. I think where this gets a little spicy is now I'm working with the vertical lines. Feel free to use a lot of pause to catch yourself. Here I'm working with the denominator, because if your denominator is 0, you will have an undefined slope or a vertical tangent line. So again, I need to find a pair of x and y's. I need to find specifically the x values that would make this work. Well, I don't have an x value. I have this equation right here, which is the denominator set equal to 0, and I have this equation right here, which is my base equation. I solve for x. I rewrite my original equation with that x. Boom, boom. I get again y equals this and y equals (16 to the 1/3 power). This curve is very symmetric, so this is very straightforward. Once I have those, I plug those again back into this definition of x, and I get these values of x. These values of x are where are my vertical lines. If I'm looking for vertical lines, I need lines that are equal to x. Please note, if I plug in this case, dy dx evaluated at 0, 0 is, or excuse me, a better example for this specific problem, dy dx evaluated at 16 to the 2/3 over 2, comma, 16 to the 1/3 is equal to. Let's just see what happens when I plug this coordinate back into my derivative. Well, 2 times y, which is 16 to the 1/3, minus this squared. 16 to the 2/3 over 2 squared over y squared, which is 16 to the 1/3 squared minus 2 times 16 to the 2/3 over 2. All I did was I plugged in this coordinate, which is this right here, back into my derivative. 2 times 16 to the 2/3 is, just some number, 1/3. This is now 16 to the 4/3 over 2. So, we don't know what this is. This is just some number. That's fine. This is 16 to the 2/3. This is, those twos cancel, 16 to the 2/3. This equals, this is some decimal, so who cares? Let's just leave it like that. That's division by 0. That means that at that x coordinate with this y coordinate, my slope will be undefined if I plug those points into my first derivative. I hope this helps. I really do. This is a big video. Thank you so much for watching. If you're watching this, I appreciate. I can't even tell you how much I appreciate.
All staff should be in the department.